This is the brief on vortex vector fields and circulation. Okay, so picture a whirlpool spinning around a drain. This whole scenario creates a math problem where, our standard calculus rules, they just kind of shatter. And it's all because of a singularity, one single point right at the center. First up, you get this really weird clash between local and global behavior. If you zoom way in on any tiny spot away from the center, the field looks totally calm, what we'd call conservative. But zoom back out to look at the whole loop enclosing that center, oh, it is definitely circulating. It's like the math tells two completely different stories. So second, and this is wild, we basically stop measuring distance and start counting loops. This is the winding number. It doesn't matter if your path is a perfect circle or some wobbly, squiggly line. Seriously, if you wrap around that center twice, you get the exact same result. The math only cares about the topology, how many times you actually circled the drain. And finally, this whole thing just breaks Stokes' theorem. That trusty tool we all use? Well, it fails here. Why? Because the origin is a singularity, a literal hole in the domain where the math just blows up. You can't simply cover the loop with the surface because that central point pierces right through it. And boom, the theorem's invalid. So when it comes down to it, in these vector fields, it's not about the path you take. It's all about that path's relationship to the singularity. That's what truly matters.